think about which one doesn't belong. There are no wrong answers. If you think you have an answer, you can hold this up, and then when we talk about answers, I'll call on you. Give you 30 more seconds. Think about which one could be the one that does not belong.
Even if you are unsure, it doesn't hurt to try. Really, there's no wrong answer on this.
Those that have an answer, either I have an answer or you have multiple. Colin? Top. Which one? Top right. Why?
Because it's 2x and the other one's x.
Okay. Anyone else think about it like that? A couple of us. This has been going off and on all day. Right. Anyone have a different answer, Mary Ellen? Bottom right. Why that one? Okay. So the variables are different. Anyone else think about it that way? And then anyone else have a different answer, Adam? Bottom left. Why that one? Okay. I tried to change the pen on this. It's not liking me today. But Adam said the ones in the bottom left are positive, where all the other ones have like a plus minus thing going on. Anyone else think about it that way? Okay. Aaron? Okay. So all the other ones have a 1 and a 4. This is the only one that has 2. Anyone else think about it that way? Anyone else have a different reason why one may be different? Let's reconnect this. There we go. Okay. So a lot of the things we said were not really, they were really non-math answers, but some of them could have been math answers, like the both being plus, the 2 in front, jumps between both. That these have 2s and the others have 4 and 1. The M, some other reasons why these may not belong. If we were to multiply this out, what happens? X times x gives us x squared. X times 2 gives us 2x. Negative 2 times x gives us negative 2x. And negative 2 times negative times positive 2 is a negative 4. What happens with that one? So the top left one is the only one where it doesn't have a middle term when you distribute it out, because all these would. This one we could also say is difference of squares. These would give you positive answers. This one would give you 2 negative answers. All of those could be reasons why any of these do not belong. So that was just a quick, short little warm-up to get you thinking. Before we do our notes for today, I wanted to mention one thing that some of you may have seen if you got progress reports over the weekend. Some of you don't know what I'm talking about. Moving forward, I am no longer replacing Khan Academy grades that have not been attempted. So if you do not attempt them, I am not replacing them with the test. That doesn't mean they can't be replaced. So if you do them and then the test grade is still higher, I will still replace them, yes. But you need to attempt them because many of you are not. Questions on that?
And that's reflecting on some of your guys' tests. So if you're not practicing individually or independently, you're not going to be confident to get the test done accurately.
Page. Yes. So even if you do them late, I will still replace like the tests with that if it's higher. Okay. So everyone should have these notes in front of them. Today is the last set of factoring notes. This is like a combination of a lot of the stuff we've talked about in this unit, GCF, grouping, not really difference of squares in this, but factoring trinomials, all those things get brought together in this. You can call this like the final boss. Okay, so I'm going to talk through the rules first, and then we'll actually do some examples. So the rules for this is like what we did last class, so if you want to get those notes out, that may help you. It also deals with some grouping stuff, so if you want to take out those notes, those may also help you. And then, of course, GCF stuff. So you're going to be given some trinomial, 3 terms, where you have an a value that is not 1 anymore. It may be you just factor out a GCF and then it becomes what we were doing last class. It may be different. So look for a GCF first. That'll be your first step always. If you have a GCF, factor it out, and that'll determine how you solve it moving forward. If that doesn't really help you moving forward or your GCF was 1, we're going to take A and C and multiply them together. You don't have to write this because it is in your test, but if that helps you, feel free to do that. After we multiply those two together, we'll get some number, and then like we did last time, we're looking for factors of that number that would add to these. Once we figure out those factors, we're going to take the middle term, take it out, replace it with the 2 factors we found. Then we'll have 4 terms instead of 3, so then we'll split it down the middle and do our grouping process. Okay. I know that was a lot in words because we didn't really do any math, but let's actually try this. So first, let's look for a GCF. Do they have something in common? No, other than 1. But we're still going to write that off to the side so we get in the mindset of checking first. The 1 wouldn't change anything, so we're not going to do anything with that. Then we're looking for 2 numbers that multiply 2 and 3 together first. And I'm going to do this thing off to the side to kind of organize some of our numbers because there'll be a lot. Draw this x. 2 times 3 is 6. So we're looking for 2 numbers that multiply to be 6, but add to be 5. I'm going to be doing this work in different colors, so if color coding helps you, you can use highlighters, color pencils, your own pens and pencils. So positive 2 and positive 3. So then we're going to rewrite our original. The first and the last term stay exactly the same. 2x squared. Then the 2 factors we found, we're now going to put it in the middle instead of the 5x. Because 5x had an x, we're also going to put x's behind them. Does not matter which one you do first. So plus 2x plus 3x. And then the last term, plus 3. before we continue? Any questions so far? Now we have 4 terms, so we can split it down the middle, and we're going back to our grouping process. What do these first 2 have in common? Two x. So if we were to divide both of these by 2x, what would be left? Here, x plus 1. So divide both of these by 2x. To get that, bring your sign down, the plus. What do these have in common? 3. So if we divide them both by 3, what's left? X plus 1. Remember that your goal of grouping, your factors have to be the same on the inside. They are. So then you can write your final factors. If the insides are the same, that's one of them. Excuse me, and everything on the outside is the other. Does not matter the order you put those. If you put 2x plus 3 first and then x plus 1, that's fine. I'm not going to do this for every single one, but if you wanted to double check to see, did you get this right? Are these the right factors? You can multiply it back out. So x times 2x would give us what? I just didn't hear it. Say it louder. Whoever said it. 2x. You're really close. We have 2 x's, so that would become squared. And then x times 3 would give us 3x. 1 times 2x would give us 2x. And 1 times 3 would give us 3. So 2x squared plus 5x plus 3 is our original. So that works. What questions do we have about any of this process before we move on to the next one? Okay, so where we got this answer from? So this, since those are the same, that becomes one of your factors. And then everything on the outside becomes your second. I know there's a lot of arrows. The things outside that we factored out of these become 1, and the things on the inside become 1. Let's do the next one. This example 2, have a GCF. They have something in common. Other than 1, so we'll write that GCF equals 1. So nothing's going to change. And then we're going to multiply 5 and 6. What would that give us? 30. So 2 numbers that multiply to be 30 but add to be negative 17. Since we're multiplying to be a positive number, the only 2 ways it can be positive is if both factors are positive or both factors are negative. So think about your factors of 30. They would both need to be negative since 17 is negative. Which factors would work? and both negative. So then we can rewrite this. 5n squared. Again, doesn't matter the order. Let's say I put 15 on the right instead of the left. But I know 5 and 15 go together because I can divide 15 by 5. I can put those together. The order does not matter. So minus 15 minus 2m plus 6. Split that down the middle. What do those first two have in common? 5m. If we divide that out, what's left? M minus 3. Bring down this negative. What did those two have in common? So if we are dividing both by a negative 2, be careful with your signs, what would be left? M plus 3, we're divided by a negative? Minus 3. Then what would those final factors be? And minus 3 is one of them. 5m minus 2. Questions so far? I think we have time to do one more before lunch and then we'll do more after. Okay. For example 3, does that have a DCF? You say yes, no. Yes, what is it? Can you divide 5 by 2? No. So just 1. It has 1, it's just 1 though. Multiply 6 and negative 4. Negative 24. So two numbers that multiply to be negative 24, but add to be negative 5. So if it's negative 24, one of your factors has to be negative. What factors would work? Multiply to be negative 24, but add to be negative 5. What are some factors we found? Okay, those multiply to be 24. If I made one of them negative, would we get negative 5? Negative 6 plus 4. Negative 4 plus 6. Okay, so what are some others? One of them has to be negative. Which one? 8. Negative 8. Positive 3. That would give us negative 24 and negative 5. Rewrite that. So if you wanted to put the 3 with the 6 and the 8 with the 4, you could do that. If you didn't do that, that's okay also. You should get the same thing either way. What do those first two have in common?
It's y.
Divide 8 by 6.
So
2y. What would be left if I divided both of them by 2y? Say that one more time. What's 6 divided by 2? 3y minus 4, yep. And then, do these have anything in common? No. So I meant to do this when we talked about groupings before, but you can always take out a 1 if there's nothing else. And then the inside would just stay the same. And really quickly, what is our final answer? What are our final factors? 3y minus 4 and 2y plus 1. You said it the opposite way, but that's, yeah, that still works. Right? We will continue this when we get back to lunch. Alright, let us continue. Thank you. I locked it again. For example 4, what is the GCF of that?
What?
GCF. What do they have in common? Nothing besides 1. Sorry, I have something in my eye. Okay, so then we are looking for what is 12 times negative 5? Negative 60, yep. So we're looking for two numbers that multiply to be negative 60, but add to be 11. We're looking for two numbers that multiply to be negative 60, but add to be 11. Sorry, what was your numbers? 15 and 4. And you said positive 15 and negative 4. Okay? So let's rewrite this. 12c squared doesn't really matter because you could take something out of both. So I'll do plus 15c minus 4c minus 5. What do those first two have in common? 3c. If we divide that out of both of these, what's left? Carry on. 4c plus 5. And then, can we take anything out of those last two? No, but we could take out a 1, and the sign is going to be negative, so negative 1. So what would that inside factor be? Be careful here, because we're just dividing, not subtracting. So then what would your final two factors be? What would those final answers be? 4c plus 5 and 3c minus 1. Questions on this so far? I'm trying to reconnect this. Alright, look at numbers 1 through 9 and see which ones you have questions on, want to see, want to go over, maybe look challenging, anything like that. 5. Maryland. 7. Elijah. 9. Alright, so we'll do those 3 and then we'll move on. So starting with 5. Does that have a DCF? No, other than 1. So then we are multiplying 10 and negative 2 to get negative 20. What is the number in front of P? 1, but negative 1. So we're looking for 2 numbers that multiply to be negative 20 but add to be negative 1. Remember that if you're adding to get 1, the 2 factors are going to be really close, like 1 apart. Say that one more time. 4 minus 5. So then we could rewrite 10p squared. I'm going to switch them so that 5 goes with the 10. So negative p plus 4p minus 1. Or I'm sorry, minus 2. What would those first 2 have in common? Mm-hmm. 5p. We divide both of those by 5p. What's left? 2p minus 1. What do these 2 have in common? 2. And it would be positive. And if we divide that out, what's left? 2p minus 1. So then what would our final factors be? That's one of them. 5. Questions on that one?
How direct before you find the factors, how do you get that
So like from here to here?
from the top, like the second step?
From here to
How do
here?
you find 5p, how do you find 5p to e minus 1?
This part?
Yeah.
Okay. So we're looking for what these 2 had in common, which was 5p. And then if we're dividing, which I'm not showing that step, but that's what we're doing. We're dividing both of these by 5p. This would give us 2p. This would give us negative 1. Other questions? Okay. On to number 7. Does this have a GCF other than 1? It is just 1. Multiply 4 and 1. 4 times 1 gives us what?
4.
So we're looking for two numbers that multiply to be 4 that add to be negative 4. Two numbers that multiply to be 4 but add to be negative 4. Negative 2, negative 2. So let's rewrite. 4a squared minus 2a minus 2a plus 1. Split it down the middle. What do those first two have in common? 2a. We divide those first two by 2a. What's left? 2a plus 1 minus. Okay. What do the last two have in common? Nothing but
Plus 1.
1. But it would be negative because this one's negative.
Okay.
So if we divide out a negative 1, what would be left? From both of these. What would that become if we divide by negative 1? And 2a minus 1. So then what would our two factors be? Do the same thing. So if you want, you can write it as 2a minus 1 squared. Alright, questions on that one? Yes. We had negative 2 twice. So from our factors, that's where that comes from. Right. And then number 9. Do we have a GCF other than 1? No, it is 1. And then we are looking for what is 6 times negative 12? So two numbers that multiply to be negative 72, but add to be 1. That gives you 72. I think 8 and 7. Oh, 8 and 9. 8 and 9. There we go. And then, which one's negative? The 8. Yep. Alright, so 6x squared, doesn't matter. Let's say I want the 9 to go first, plus 9x minus 8x. If you did it the other way, that's fine. minus 12. Split it down the middle. What do those first two have in common? 3x. If you did 8, then yes, 2x. If you did 8 first, it'll be 2x. Still do it the same way. What would be left? This 3. If you put 8 in the middle, you'll have something different on the inside. At the end, it should all work out. What did these have in common? 4, but it would be negative. And if we divide out negative 4, what's left? 2x plus 3. And what would our final factors be?
2x plus 3, 4, 3x.
So if you put 8 first, you would have 2x plus 3 here and 3x minus 4 on the inside. It would just be switched, and that's okay.
Would that be a wrong answer?
The order does not matter. Questions on that? Before we move on to some more challenging ones, how do we feel about this process overall? Good. I get this. Okay. I just need some more practice. Not good. I don't understand at all. Yeah. Okay. And you'll get that practice time here in a little bit. So we're going to do number 10, and we're going to do it 2 different ways, and then we'll do one more together, and then any you guys want to see, and then you'll have time to practice. Okay. Does this have a GCF other than 1? And what is it? If so. So if we divided everything by 4, what would be left? Squared minus minus
6.
Now we're going to do the same process and just keep dragging the 4 along. So multiply 5 times negative 6. Negative 30. So we're looking for 2 numbers that multiply to be negative 30, but add to be negative 13. Be careful, because one has to be negative.
You know
The
what I'm
opposite.
saying, yeah.
Negative 15 and positive 2, yes. You kept switching the numbers but keeping the sign. That's what was going on there. Alright, so let's rewrite. That is the only way. 13 and 3 wouldn't work because only 1 can be negative. Okay, so then we have our original, and I'm not supposed to be doing this in blue. Sorry, I'm going to color code this to keep stuff the same. So 5n squared would stay the same. The 4 on the outside, we would just keep bringing that along. Then we have our 2 in the middle, the negative 15 and the 2. And then minus 6. Then we would split that down the middle. bringing down your 4, what could you divide out of 5n squared and negative 15n? 5n. If you divided out 5n, what would be left? 1n minus 3. What could you divide out of these last two? 2. Positive 2. And what would be left? N minus 3. So then what would we write as our final factors? And I forgot a parentheses. N minus 3 is correct. 4 plus what? We wouldn't put those together. Okay, where would we put the 4? You just keep bringing that down. If you lose that and go to multiply it back out, you will not get the same thing. So be careful with that. Okay. Before we multiply that out, I'm going to show you the other way you could possibly do this. I wouldn't suggest this. Always look for a DCF. Is what I'm going to suggest. But on just in case, because life happens and we forget stuff, rewrite that problem in your blank space. Let's say we forget to check for a GCF first, and then we start multiplying these two together. What would 20 times negative 24 give us? Use your calculator. So we're looking for two numbers that multiply to be negative 480, but add to be negative 50. This is why I would suggest this, because I don't know the factors of 480, and you'd have to either make a list, start guessing, things like that. So I would say if you forget to do a GCF and you get something that's a big number, see if there's a big number or somewhat big number you could divide it by. Like, this is something that ends in a 0, so I can divide it by 10 or 5. 10 would be better. 20 would also work. And then kind of go from there. I know negative 48 and 10 or vice versa would work. I'm just going to put 48 and 10 for now. But if I made one of those negative and added them together, would we get 52? Negative 52? No. So then, this is close, the number we would get, but not that close. So from 10, either start to go up or start to go down. If we divide 480 by 9, would that work? No. What about 8? We have 8 and 60 and make one of those negative. Would that work? Which one would have to be negative? Okay. Negative 60 and positive 8. And then we would still do the same process. So 20n squared minus 60n plus 8n minus 24. And then if we split that in the middle, what would those first two have in common? divide both of these by the highest thing we can divide them both by. Five works, is not the highest. Can we divide 20 by 6? 10 works, but it's not the highest. 20. Okay, so if we divide, 20 what? N. We divide both of those by 20n, what would be left? N minus, what was that last one? 3. We're dividing it by 20. Okay, what do these last two have in common? Positive 8. If we divide that out, what's left? So then our two factors we have would be 20n plus 8 and n minus 3. Are these our final answers, or could we take something else out of one of them? Of this one. What do those have in common? 4. So if I took 4 out of just this first one, what's left? 5n plus 2. And that should match the original we have. So even if you don't do the GCF first, as long as you do it later, that's fine. I wouldn't recommend that because you'll end up with really big numbers, but you could still do that. I'm going to multiply this out really fast so we make sure that our work is right. So we do this part first. This would give us 20n plus 8, which we knew that already. And then multiply these together. 20n squared minus 16n plus 8n minus 24. Which does give us 20n squared minus 52n minus 24. So we got the right factors.
That just seems like it's a lot longer to do. Yeah, a little bit chaotic, but it's still a process. That
Yes.
This is the right answer. So, check for GCF.
Let's do 11, and then any others you guys want to see, and then we'll be done. What is the GCF of 11? 5, yes. We divide these all by 5, what's left? A squared plus what's 75 divided by 5? 15. Okay. And then the last one, 35 divided by 5? Then we are multiplying 2 and 7, which would give us what? 10, 7 is what? There we go. We're looking for two numbers that multiply to be 14 but add to be 15. Remember, if those two are close, one of your factors is going to be 1. So what would our two factors be? 14 and
14 times 1 is 14. 14 plus 1 is 15.
then we have bring down your GCF, bring down your first term, put your 2 in the middle, plus 14k plus 1k, or just plus k, either or. plus 7. Split it down the middle. Bring your GCF down again. What do those first two have in common? K squared and 14k. What do those have in common? Say that last part again. We divide those two by 2k. What's left? Can we, what does, yeah, sure. What do these have in common? 1. So that would just leave us with k plus 7. What would our final answer be?
8 plus 7. Or 3k plus
Missing something. 5. Are there any others we want to see in this section 12 through 15?
12.
Okay. So we'll do 12 and then I'll let you guys practice. Does this have a GCF and what is it? 2. So if we divide everything by 2, what's left?
6x squared.
Plus?
1x.
I didn't put the 1, but you could put the 1. Minus?
1.
So then we are multiplying 6 and negative 1, so negative 6. Looking for two numbers that multiply to be that, but add to be 1. Numbers that multiply to be negative 6, but add to be 1.
Negative 2, 3.
Negative 2 and positive 3, that would work. So let's rewrite. Bring down your DCF. 2 and then 6x squared. Put your two middle terms in there. Negative 2x plus 3x. And then our last term minus 1. Bring down your DCF again. What do those first two have in common? 2x. And then if we divide those two by 2x, what's left?
3x.
Do these last two have something in common? One. Which would just leave us with 3x minus 1. So what would our final answer look like?
2, 3x minus 1. And 2x plus 1.
And then 2 in the above. You guys have those 3 Khan Academy quizzes due Friday. The ones from last week if you didn't do those, and the one from the week before if you haven't done that. As well as this practice. use this time wisely, get whatever practice you need, ask questions, get help if needed, and let us know if you have any questions.